We are now on the session 2 of unit 4. Session 2, probability distribution of discrete random variable. By the end of this session, we should be able to describe probability distribution of a random variable, solve problem involving a discrete random variable distribution. Probability distribution of a discrete random variable x is defined as a sequence of the values xi, where I varies from 1, 2, 3 up to the nth number of x, together with their corresponding probabilities assigned to the xi. So as you can see from the table, each probability, like x1, has its discrete random variable x1, has its corresponding probability up to the last probability. So this is a probability distribution function of a discrete random variable. Definition: any function p of x defined on all possible values of x, and x takes values from I, or xi take values from 1, 2, 3 up to the nth number, is called PMF. That is probability mass function if it satisfies the following condition. Now, if it is called PMF when the following conditions are satisfied. 1, that a random variable x, assuming the small x, should have its corresponding probability, and that each probability ranges from the values between 0 and 1. And when we sum up all the probability under the random variable of that distribution, it should be equal to 1. It should be equal to 1. Example 1. A fair coin is tossed 3 times. If x represents the number of hairs that shows up. Now we are being tasked to do what? List the element of the sample space, corresponding values and probability of occurrence. The B says we should find the probability distribution of x. That is the problem. Solution. Now the probability of each outcome is 1 over 8. Why do we say it's 1 over 8? Since tossing a fair coin 3 times, we have 8 outcomes, and each outcome will be 1 out of 8. So looking at events, so you have, if the interest is the number of hairs, so you see the first event you have t, to mean that no head. The second you have 1 head. The third one you have 1 head, and moving forward you have 2 heads somewhere, and you have also 3 heads. Now, so x is the random variable, or the random value that is assigned to the outcome. So you have 0, 1, 2, 1, 1, 1, 1, 2, 2, 2 up to 3, and each has its corresponding probability. A probability of x assuming small x, and since there are 8 outcomes, each has 1 out of 8 as its probability. Looking at the B part of the question, we have to find the probability distribution of x. How do we get a distribution of x? We already made it clear that the probability of each outcome is 1 on 8. So probability of x, random variable x, assuming 0, that x equal to 0, we have 1 over 8. Probability of x equal to 1. Now x equal to 1, we have 3 of them. So you have 1 over 8 plus 1 over 8 plus 1 over 8, that will give us 3 over 8. That of x equal to 2 also will give us 3 over 8. And that of x equal to 3 will give us 1 over 8. So therefore, the PMF, probability mass function of x, is giving us x assuming values from 0, 1, 2, 3, has its corresponding probabilities. And of course, when you sum out all the probabilities, it should be equal to 1. That made it a PMF. And each probability also is between 0 and 1. That's quite interesting, right? Let's work on example 2. Example 2. A function p of x is defined by, so that's the definition, that the p of x equal to 1 over 2 multiplying the expression 2x plus 3, where x assume values from 1 to 3 or 0 elsewhere. Now, what is the task here? Ours is to verify that the probability of x is a discrete random variable. In another word, it is PMF, probability mass function. So solution. Since x assume values from 1 to 3, ours is to substitute the values of x equal to 1 up to 3 as we sum along from the function given. Right? Good. So the function, that is, if x is 1, we have 2 plus 3, giving us 5. When x is 2, we have 4 plus 3, giving us 7. And when x is 3, we have 2 times 3. That's giving us 6 plus 3, giving us 9. Summing all will give us 21. Multiply with 21. Or sorry, 21 multiply with 1 on 21. And that will give us 1. So what is the conclusion? We will conclude that yes, hence probability of x is a PMF. It's a PMF.